Hello, SCDOT members. My name is Joe Burgett, and it's my pleasure to be to present a study that I did with the SCDOT as part of this Lightning Talk series. So, what I'd like to speak to during this presentation, like I said, is a study that we did with the SCDOT where we used drones to augment and support the SCDOT's bridge inspection program. So, with that, let me kind of go talk through a little bit about how it's done now. So, as you may be aware, we got a whole bunch of bridges in the state, and they are inspected routinely, and the frequency between them varies 1, 2, maybe 4 years, depending upon the condition of the bridge, how recently it was installed, and again the overall conditions. So what will happen is a bridge inspection team, 2 or 3 individuals, will go to the bridge and review it. They're engineers, and they look at it, and there's certain things that they look for, like at the deck level, where the cars are going over the deck. They'll look for delaminated concrete, the conditions of the asphalt, cracking, and take measurements about how much of that is going on, so they can compare it year over year. They might also look for spalled concrete. What commonly happens when rebar is made of steel. As steel gets wet, it oxidizes and rust, and that rust will then push back and expand and put some pressure on the concrete, will then spall it off, will delaminate it, and it'll lose its integrity. Or just, they'll look for things like rust, which again are just another symptom of that, or maybe just water. That might be the first sign of some of those things that might happen. So the way that they do it is they'll, again, physically go out to the bridge site, walk the deck, put their eyes on it, look at it, take measurements, see how things are going over time. Bridges oftentimes go over a body of water, so if it's a smaller stream or river, they might use a kayak or a boat, or if it's a more significantly larger structure, they might use it's called a U-bit, or an under bridge inspection truck. So here's a few pictures of them, and as you can see in let's see, the lower picture there is a picture of the truck. These are large pieces of equipment, $1 million+ dollars. The state owns 3 of them that the bridge inspectors share. If there's over demand, they can rent them. So there's a cost associated with these pieces of equipment. When they're set up on the bridge itself, they take up space. They will, obviously they're about as big as a normal truck, so they're going to take up either a lane or travel lane, so that can have some disruption to traffic. If you're in the buckets, these are, they're dangerous pieces of equipment. That bucket goes up and down, especially when you're articulated far out on that boom. They move. There's some dangers associated with that, of course, and if a car were to crash into that truck, so, there's some danger associated with it. They're slow moving, but that is a way to get the inspector right there underneath the bridge to be able to inspect things. Again, for a bridge, the structure is where a lot of the interesting things happen that need to be reviewed to make sure that the bridge is safe. So a lot other DOTs are exploring drones for their bridge inspections, so SCDOT wanted to explore with it too. So we set up an experiment where we got some equipment and we wanted to test it out, and there were some things that we had in our mind of what we could expect, but we wanted to, sometimes the best way to really see what you can do is just by doing it. So we picked out a good test case, the Bates Bridge, which is located a little south of Columbia. It's over the Congaree River. It's about a half-mile long. There's a picture of it on the slide here. It's a concrete structure bridge, 2-lane. So with that U-bit truck, one of the lanes did need to be shut down, so that necessitated some flagging and traffic only going one way at a time. It was in Class G airspace, which facilitated our experiment. There's actually a nice parking lot there near a boat ramp, so we were able to set up there. So it's a good place for some experimentation. Another advantage, it had been recently inspected, so we did have a report of where the deficiencies were at, or the things to keep an eye on were documented. So we had that, and we conducted 2 experiments with 2 different bridge inspection crews. So the first was the bridge inspectors, bridge inspecting engineers, who had done the original inspections and were intimately aware of this bridge and knew all the conditions of it and created that report. So that experiment, we had the bridge inspectors, we shadowed them and we teamed up, and then they inspected that bridge with the drone, knowing where those defects were at. Experiment number 2 is where we did the same thing, but with a different bridge inspection team who didn't know anything about this bridge. And then the idea was, can that team use a drone and being able to find all of the deficiencies that were done using traditional methods and and that the first inspection team had been able to find. So the equipment that we used, the drone is in picture number 1 there. It's a DJI M210 RTK. That RTK, that's that base station there, is in picture number 2 that we set up. Number 3, again, that's just the drone itself with the 2 controllers. Again, one where the pilot I would fly, and then the bridge inspector would have the other controller and be able to manipulate the camera and see what they needed to see. And then in picture number 4 is the battery charging station. We had a surplus of batteries and were able to charge in real time so that we could charge up our drone at the same speed that we were depleting them. So again, as I said, there's an example of the team. We had a team of 4 where I was the pilot. We had a bridge inspector who was manipulating the controls and able to move the camera around to be able to see what they needed to see. A third person was, reading off or taking notes, either reading off the deficiencies in the case of the first crew, or just writing down the deficiencies noted in the second. And then we had a visual observer following us along the way. Let's go ahead and one of the things that we had found was a zoom. So if you could look to the picture, hopefully it keeps up here. But we had a zoom on the camera, or on the drone. It was a Z30 DJI and had incredible zoom power, which allowed us to had a 30 times optical zoom. So we were able to actually stay pretty far away from the bridge and still be able to zoom in to see the things that we needed to see, the bearing pads, bolts, and those sort of things. What did we learn? So overall, this was a great tool. We were able to navigate the bridge safely, staying off from obstructions. We had a known list of inspection points. I don't want to call them deficiencies, but we had inspection points, and we were able to see 91% of those in both of the crews, in the original crew inspection team that inspected the bridge, as well as the other team that was unfamiliar with the bridge. 91% of the inspection points. There was, again, 9% that was either too dark or we couldn't see. The zoom was a very powerful tool. There is a little bit of a debate about if you have a heavier, more costly aircraft that can support that zoom, or if you go with I don't want to call them disposable drones, but a lower cost drone that you just fly the drone closer to be able to get the same image quality, but are flying closer and could increase the risk of damaging the aircraft. There's a little bit of a debate there about which one is better. We found that 4-person crew was pretty vital because the pilot, especially in a GPS denied environment, is doing only flying that drone. They're not paying attention to anything else. The inspector is doing nothing but looking at their controller and looking for inspections. They're not paying attention to anything else. The note taker has got their nose down and taking notes and reading off inspection. And we really need that 4th person to really maintain situational awareness for cars that might be coming by and that sort of thing. And what we found is it really, started out a little slow with the crews being unfamiliar with drones, but overall, our efficiency increased significantly over time. It did not take very long for us to really ramp up efficiency. We also, using this drone, would not have replaced the U-bit truck, but like I said, it would have significantly reduced the amount of time that we needed it, and that lane would have been closed. So traffic disruption would have been significantly less using a drone over a U-bit. We were able to fly that drone without really the general public knowing at all. When we got above the roof deck, we launched at hundreds of yards away. We went up to a high elevation, and we were able to see everything that we needed to see without anyone knowing we were there. The inspecting crew and the pilots were far away from oncoming traffic, so there was a reduced safety issue there. And the documentation was just phenomenal, whether it be just 2D images or the 3D models that we created. And overall, we did an estimate that we assumed or estimated that by using a drone for this one bridge, for this one inspection, had an estimated savings of $1,500. We were pretty pleased with that. Now, a few things just kind of carrying over. A drone is not a replacement for an in-person inspection. You still need to be able to go out there and drag a chain, knock on concrete, sound out things if things are hollow, put your hands on it. So it's not a replacement for everything, but it's a good supplement, especially for routine inspections. We could not get the aircraft everywhere. There were some dark corners where we just couldn't get the camera angle right to be able to see in there, some dark areas. As I mentioned, there's a trade-off between larger aircraft aircraft and smaller aircraft with cost versus risk of colliding, being able to support a zoom camera. As I said, could not do that tactile contact to be able to actually put your hands on it, so there's a limitation with that. There was some low light conditions, as I mentioned, where we couldn't see everything, and most we could, but not everything. Flying in a GPS environment as a pilot who operated it, that can be nerve-wracking. Wind, not being able to rely on that hover mode is definitely something that you need to have some skills to be able to navigate that. And just, working around obstructions. The Bates Bridge didn't have a lot of obstructions, but a lot of other bridges do, with vegetation growing and fishing line being hung. So there are some limitations there. Not the answer for everything, but a very, very valuable tool in the toolkit. Where we see this going is live streaming. That the drones do have the capability of doing that if you have access to Wi-Fi or cellular connection, and you can live stream your inspection to someone else at the office. And we actually did do a little bit of that as well with another experiment that was which was successful, very promising. And then exploring more 3D modeling, being able to take 2D images and create higher resolution 3D images that can either be inspected later or by another person who wasn't navigating and operating the drone, or just better and enhanced documentation. So a lot of promise there. Thanks, everybody. Thank you to the research committee for allowing me this time to kind of share briefly during this lightning talk. Thank you for the time, and thanks everyone for watching.